Okay, so as mentioned in the vocab, for each of these, we have to do several things, right? Find the degree. We have to name them. We have to add them, subtract them, things like that. So starting out simply, find the degree of the monomial. Again, monomial there. Make sure we know what that word means. And remember, monomials have no addition, no subtraction. It's multiplication. And in this case, we take a look at the variable, and the degree of the x is 1. Therefore, the degree of the monomial is 1. Here, we take a look at the x cubed, y squared. Again, the 6 does not have a degree. And we add them to get a degree of 5 overall. And other than knowing the degree of the monomial, that's all it does for you. It's not useful in any other circumstance. Here, degree is 0 because there's no variable. You could say x to the 0 power if you prefer, but again, degree of 0. So degrees here, let's take a look at A. 8xy. So the x has a degree of 1, the y has a degree of 1. Together it's a degree of 2. Taking a look here, the y has a degree of 4, the z degree of 1, add them together, degree of 5. And this has no variable, therefore a degree of 0. Adding and subtracting monomials involves nothing more than just combining like terms. So if I take a look here, I have 3x squared plus 5x squared, that's 8x squared. Here I have 4x cubed y minus 1x cubed y. Notice, same degree and same variable, the same power. That's what I'm trying to spit out here. So 4 minus 1 is 3x cubed y. Again, combining like terms. So if we take a look here, what is the sum of these two? Notice, x to the fourth, x to the fourth. So negative 6x to the fourth plus 11x to the fourth is 5x to the fourth. And over here again, verify first that they have the same variable, the same power. So 2x squared y4, 7x squared y4. So 2 of these minus 7 of those is negative 5x squared y4s. Alrighty, so we're going to classify polynomials, and we can do that with two things. We can name them based on the degree and name them on the number of terms. So taking a look here, 3x plus 4x squared, not standard form, right? So put it in standard form first. Again, that's alphabetical and descending exponents. So 4x squared plus 3x. Again, remember, you can't add those into some strange 7x something. This is a quadratic binomial. Again, binomial because we have two terms, right? And quadratic because of the squared. You can use this chart I brought down here to help you with that. Alrighty, so second one, 4x minus 1 plus 5x cubed plus 7x. Again, put it in standard form. Combine like terms. That is important. In this case, 4x and 7x is 11x. Now, we can see it's cubic, the cubed here, and again, 3 of them makes it a trinomial. So, same thing here. Put this in standard form first. So notice here, it's not. So the 8x squared would come first, plus 2x minus 3. You can see that down here. And it's quadratic because of the squared, trinomial because there's 3 terms. And how does writing a polynomial in standard form help you name it? Well, in my opinion, doing that helps make sure that you combine like terms, so you catch if there's like terms to combine. Also, you can see what the highest power is, right? So you know how to name it, and you can see the number of terms in once you combine like terms. Again, also helping you to name it. Alrighty, adding polynomials. Little story problem fun for us here. A researcher studied the number of overnight stays in U.S. National Park Service's campgrounds in the backcountry of the National Park System over a 5-year period. The researcher modeled the results in thousands with the following polynomials. And this is where this actually does happen. Usually you see these in computer models. So campgrounds, right, and backcountry here. In each polynomial, x equals 0 corresponds to the first year in the 5-year period. I think we've seen stuff like this, right, when we talk about growth. What polynomial models the total number of overnight stays in both campgrounds and backcountry? Means we're just going to add these two. Okay, so to do that, make sure first off they're in standard form, which these are. And then we can go through and we add like terms or combine like terms. So negative 7.1x squared plus 21x squared is a positive 13.9x squared. Negative 180x minus 140x, or plus negative 140x if you prefer, is negative 320x. And 5800 plus 1900 is 7700. Again, throw in the 0, that would be that first year of the study. Some people like to do it horizontally and then combine like terms. That's fine. You can do the same thing. I don't care which model you use. This is kind of nice because you get to see it. And again, this is the overall for the two combined because you've added them. Okay, so another story problem, pretty much doing the same thing. We're just going to add two polynomials. A nutritionist studied the U.S. consumption of carrots and celery and of broccoli over a 6-year period. Ooh, yum. The nutritionist modeled the results in millions of pounds with the following polynomials. So here's carrots and celery. Here's broccoli, so eat your veggies. In each polynomial, x is 0, again, corresponds to the first year of the 6-year period. What polynomial models the total number of pounds in millions of carrots, celery, and broccoli consumed during the 6-year period? So again, what we're doing is adding these two together. So we're going to have 12 x cubed, or negative, I almost forgot that in front there, plus 106x squared minus 241x plus 4477. And we're going to add to that. Now notice I'm going to line them up with like terms here. Be careful, this 14x squared. We're going to line up 14x squared minus 14x plus 1545. And then we're going to go through and combine like terms. Nothing to combine with the first term here, so whoops, no, that's not what I intended to have happen. There we go. Thought I grabbed this. That's better. Alrighty, so that's going to carry down negative 12x cubed, and then we're going to add 106x squareds and 14x squareds, which is 120x squareds, and then negative 241x and negative 14x, which is negative 255x, and finally 4477 and 1545, which is plus 6022. That's fun, isn't it? Now, if you think back to when we used the elimination method for combining linear equations, solving systems of equations, rather, subtracting is kind of the same thing here. I would recommend, if you're going to subtract these two polynomials, again, first put them in standard form, but then I'm just going to run this negative 1 all the way through the second one, and then just add instead. So again, what that looks like right here, run the negative 1 through it, so negative 7x cubed minus 5x squared. Leave a blank because there's no x, plus 0x we prefer. And then negative 12 times negative 1 is plus 12. And then just go through and add them. So again, combine like terms here. So negative 6x squareds, negative 8x squared, negative 6x cubed rather, negative 8x squared, plus 5x, and then plus 12. Again, be sure you line up like terms and do that. Do the same thing here if you like, and again, just go back and combine like terms. Similar story on this one. I'm going to line them up here. Negative 4m cubed minus m plus 9. And then we're going to run this negative 1 through here. That's going to be, let's see, I'm going to switch colors. That's going to be, oh, you know what? I'm missing one here. Just a second. Should have left a space in this one. I wasn't really paying attention. There was 0x squareds there. So I'm going to rewrite that. We're going to have negative 4m cubed, and then plus 0, right, m squared, I don't have any of those, minus m plus 9. Now we can take and run a negative 1 through the second one. That's going to be negative 4m squared minus m plus 12. Again, negative times negative is positive. Now we go back and combine like terms. Negative 4m cubed minus 4m squared minus 2m plus 21. And that's it.